All right, so this is number 11 in 4.4 homework. So first of all, critical numbers of f. Oh, I didn't mean for the answers to be there. Oh well. So critical numbers of f. So how would you think your way through this? Well, critical numbers of f, by definition, are simply where f prime is equal to 0 or where f prime does not exist. So that is what critical numbers of f are. We have a graph of f prime. So places where f prime is equal to 0 are at x equals 0 and at x equals 1. Part B, where is f increasing? So if we think about how kind of these two problems together, think about when you do your sign analysis and you put your critical points on your number line and you sub into f prime and you determine where f prime is positive and negative so that you can make conclusions about where f would be increasing or decreasing. So if I look at values that are negative values, so if I'm looking at negative values, so in this first part of the graph here, so all of those values are going to be places where f prime is positive, and if f prime is positive, that's going to be where f is increasing. And really the same thing then, but in reverse, I guess. So now if I want to think about places where f is going to be decreasing, that's going to be when f prime is negative. So if I think about this region of the graph right here, that is going to be where f prime is negative in those areas. And when f prime is negative, we know f is decreasing. And then going back, again, when f prime is positive, so anything greater than 1 is going to be where f prime is positive. And when f prime is positive, that is where f is increasing. So f is increasing, we can see from negative infinity to 0, and then again from 1 to infinity. Again, I prefer parentheses in those. Your book has a bracket here in the answer, but just put a parenthesis, it should take it. And then where is f decreasing? Well, f was decreasing on the interval from 0 to 1. And now, again, kind of just continuing to think about your sign analysis here, looking back then at extrema, we can look back at the work that we've just done up above here. So places where a function would change from increasing to decreasing means that at x equals 0, this is going to be the location of a local max. If we change from decreasing to increasing, that x equals 1 is going to be the location of a local min. So we have a local min at x equals 1. We have a local max at x equals 0. All right, now when we think about concavity. So concavity, when you think about let's think about what you typically do with your sign analysis. So when you're making conclusions about the concavity on f, that comes from looking at where the second derivative is positive or negative. So if we take a look at where our second derivative is, and on this graph when we start off, our second derivative is negative everywhere before this point at the cube root of 1/4. Oops. So right here at the cube root of 1/4. So that's when our second derivative was equal to 0. All right, so where the second derivative was negative, what I have highlighted up above in blue, when a second derivative is negative, that's when we know the original function is concave down. When the second derivative is positive, so if we look at where our second derivative is positive, so when the second derivative there is positive, that's going to be when the graph of the original function is concave up. All right, so we were concave up from, and we can see, well, I'm just going to circle, so from the cube root of 1/4 to infinity, that's where we were concave up. We were concave down from negative infinity to the cube root of 4, and inflection points are going to be at these x locations where we change from concave down to concave up. So that's where our inflection points would be, in this case the cube root of 1/4.